And hello everyone, welcome back to another Golang tutorial. So in the previous tutorial we did the basics of getting our first program up and running. If you haven't seen that video, I do recommend you do, because it does cover a lot of basic things that are important when you work with a Go project. Anyhow, in this tutorial we'll be talking about variables and data types. So let's start off with the basics. Let's declare our first variable. So we can say name and then colon equals and then Jack in double quotation marks. Now, this is how you declare a variable. And let me just quickly print this out. So just say name. And I'm going to explain what all of this is in a second. As you can see, we print out Jack. So one way I like to look at variables is like a box. Now, when you have a box, you can put things inside of that box. And the box itself, in this case, is what's a variable. And you can put something inside of that variable or put something inside of the box. And then you can take that box with you wherever you go, and you can just take out of that box whatever you need. For example, in this scenario, we are putting Jack into a box. We then carry around the box, and then whenever we need Jack, we just go, oh, Jack is in that box. Let me quickly go get him. As simple as that. So this right here, it's a container. It just keeps something for us. It's a box. It stores something. In this scenario, it's storing Jack. And we can use this at multiple places. For example, let's actually create another variable. Here we can say age, and we can make that 18, or let's make it 19, that works fine as well. We can then say name. And you'll notice with this print statement, I'm using commas. This is almost the equivalent of the printf that we talked about in the previous video. So here we could do something like %s, for example. It is pretty cool. I wish I was older because %d is a little young. And in here we can now also specify age. So these are two different print statements, just to show you that now you can use variables with them. But in the first one, we're saying my name is, and a name, and this name is just a box containing Jack. So my name is Jack. And I am age, and there you can see age is a box that contains the number 19 years old. And here we're saying, I like my name, %s, which we know can work with text. And here we have a piece of text. Name is keeping the word Jack, as you can see there. It's pretty cool. And I wish I was older because %d, because I can hold digits or numbers, and age is a number, is a little young. Now if I run this, you'll notice, if I just resize this a bit, my name is Jack, and I am 19 years old. I like my name, Jack. It's pretty cool. I wish I was older because 19 is a little young. So that is the appeal of variables. You can declare something once, and then you can reuse it everywhere. In this scenario, it's only 2 lines of code. But in the future, you'll notice we can have up to 50 lines of code. And if we, at every 50 lines, specified Jack, for example, where name is. So here we can say Jack, and here we can say Jack as well. And here we can say 19, and in here we can also say 19. Let's actually remove these and just say 19. Like that. And here we can remove this as well. Now we're saying this, and we can remove these there, and we can remove that. And this will work perfectly fine. If I run this, you'll notice my name is Jack and I'm 19 years old. I like my name Jack. It's pretty cool. I wish I was older because 19 is a little young. But what if I wanted to change the name from Jack to Nick? Then I'll have to go here and say Nick. And then I'll have to go here as well and say Nick. And what if I wanted to change the age from 19 to 30? Then I'll have to go here and I'll have to change it to 30. Now this is only 2 lines of code. But if this was 50 lines of code, it would be a lot less enjoyable having to do this. Because we changed it, as you can see there's 30 and there's Nick. However, it was kind of a pain to do so. We had to change it at multiple locations. Now if we go back to our previous example we had, then if we run this again, you'll notice it works. But if I change the name here from Jack to Nick, and the age from 19 to 30, then you'll notice it changed the name and the age everywhere. So here it was Jack and 19, and here it was Nick and 30. And that is why we love variables so we can put it all at one place, and in once we change it, it changes that value everywhere. There's also another way you can declare variables. If you're coming from a language such as C++ or NIM or C or Java or Kotlin, you'll notice that we don't really declare our stuff as integers or strings or bools, which we'll get to in a second. We just do this. However, you can do this. Say name, so var name, and then say string is equal to Nick. This is allowed. This basically means this right here has to be a string once we declare it here. This right here just basically says this is an int. So here we tell the compiler, or we tell the programming language, whatnot, that this should be a string. We are saying this should be a string. And here we're saying, hey, you can decide what this is. So this right here is like using the auto keyword in C++. If you have no idea what the auto keyword is, no need to worry about it. But here, it's basically declaring this as a number for us. And here we're saying we want this to be a string. A string is a piece of text. So anything can be a piece of text. If we go here and say Jack, that's a piece of text. That's a piece of text. That's a piece of text. And about anything inside double quotation marks can be considered a piece of text. So if I were to change this to like that, that would be a piece of text. Run it, as you can see it changes everywhere. I'm just going to maybe remove this part here and just keep this. Also clean it up a little bit. And if I change this to 67, it will work perfectly fine. My name is 67 and I'm 30 years old. However, you'll notice as soon as I remove these double quotes, we get an error here. Because this cannot be 67, since it's an int. An int is a number. We'll get more into that in a second. So we can't do this because this is not a piece of text. It's not inside of double quotes. So if we were to run it, we'll get an error. Same with if we were to use single quotes and then a letter. This is not a string. This is a char, or also known as a letter. So if we are trying to run this, it's going to say, hey, you can't, because that's not a string. That's not a piece of text. That's a letter. So cool. Now that we know the basics of how these work, that's cool. So if we were to just do this here, whatever we put in here will determine what it is. So this will make it a string. This will make it a char. A char can only be one letter. This will make it an integer. And this will make it a float. So let me explain all of these data types I'm mentioning. So I'm not going to mention all of the data types in this video, but these are the most common and basic. First you have your string, which is a word. We did the string right here, so we can do this. Next up, you have your integer. So var age int, like that. And an integer is any whole number. So this can be -5, 24, 3,940, 69, 420, whatever you want to throw in here, that's a number. Take note, it cannot have a dot anything. This is a float, which we'll get to. So this is an integer. Then you also have your floats, so float. And here you have to specify whether it is a float 32 or a float 64. A float 32 uses less memory, so it takes up less space in the RAM. But on the downside, it cannot hold a lot of digits or a lot after this. Nah, I don't want to keep putting letters there. So it cannot hold a lot of this right here. However, a float 64 uses about double the memory, so double the RAM, but it can hold more items here. So it's just what you basically need. If you need real hardcore precision, float 64 is better than float 32. Just take note of that. You also have your bool. So here we can say var x is equal to bool, and not equal to, it's bool, and that is true. A bool is yes or no, true or false, where true is equal to yes and false is equal to no. We'll get deeper into Booleans in a future video where we talk about if statements or logical programming, but right now it's perfectly fine. But just take note, Booleans can be true or false, yes or no. Now let's talk about scoping. We'll get deeper into scoping in a future video. For right now, we don't have to go too deep into scoping since most of it won't be that necessary at the moment. Now, currently what is declared inside of this main here cannot be used anywhere else. We cannot use it outside of this main. We cannot use it in another file, nothing. However, we can also declare something here, which is global scope to the package. So var s is equal to 9, for example, and that should be string is equal to 9. That can't be a string, that should be an int, my bad. So for example, var s int is equal to 9. Now we can use this anywhere inside of this file and not just inside of this main function right here. So if we create another function, which we're not going to do right now, but if we were to create another function similar to the main function, this s can be used within that function. Whilst here, it cannot. Here, it can only be used inside of this function. We'll talk more about this once we get to functions or into if statements. But right now, just take note, this can be used anywhere inside of this file. It is important to take note of. In a lot of programming languages, if you create a constant, for example, I'm not going to create a constant right now because that can kind of take its own video. So I'm going to say var, and let's go here and say user name. So if you declare a constant, which is a variable that cannot change, then in most languages you do this. That would be a string and then equal this. So in other languages, this would mean, since it's all caps, this cannot be changed. However, since this is in Go, you should be careful because this right here can be used anywhere within this file, but it's still scoped to this file. However, this right here is not scoped to this file alone. This right here is scoped to everywhere. This is full global scope. The reason for that is because the very first letter, if that is a capital case, then that means it should be exported and it can be used in a global scope, so other files can use this. Usually you do not want this, and I'll explain in a later video why you'd not want this. But this can be exported or used outside of this file, while this can be used only inside of this file. This is why fmt.println starts with a capital P, because this word right here should be exported to outside of this file right here. This fmt, that's just a file. And this right here says this print line should be exported and usable outside of this file. So you won't just find anything that has a lowercase p or a lowercase letter like that. So just take note, if it has an uppercase first letter, which means var hello is equal to whatnot, this right here, this will be exported. This will be exported. This will not be exported. This can only be used inside of this file. And this can only be used inside of this function. So this cannot be used outside of it. Now, for the last thing I want to talk about is how you can declare multiple variables in a file scope without having to say var all the time. Because as you see here, you constantly say var. And here we also constantly had to say var. But if you just want to declare a bunch of things, at the start, you can go var, and then in brackets, we can do something like name string equal Jack. And here we can say age int equal 90. And e float equals, there we go, and I just go float 32 or something. And here we can of course put another letter and say bool is equal to false. So you can use this right here to basically just leave out having to constantly say var, because it's usually recommended that you do this method instead of doing this method. So let's just go p becomes whatnot, because once this is perfectly fine, it's recommended to specify the data type you want in here, because this also tells a different developer that might be coming to this code base. So if you work with multiple developers, then once that developer comes back here, they'll be like, so in this variable you actually want to store this data type. So yeah, that is all I wanted to talk about for today. Thank you for watching. I hope you all enjoyed, and I will see you all again in the next Golang tutorial.